Hello everyone, welcome to my YouTube channel. My name is Precious. Right, so if you are new to our YouTube channel, please kindly subscribe. In this video, we are going to look at the concept of, or rather in the next few series, we are going to consider squares and square roots. And of course, there are products of what we have seen under factors. So it's going to also play a huge role here. Okay, so these are the objectives we'll cover in this series. We'll see what a perfect square is, how to find the perfect squares of a whole number, and how to find the square root of perfect squares. Then we'll solve some quantitative problems. All right, so what is a perfect square? All right, so a number is called a perfect square when it is the product of a whole number by itself. Okay, so when a whole number multiplies itself, what it produces is a perfect square. For instance, if I have 2 times 2, I am going to get a number 4, and so 4 is a perfect square of 2. 1 by 1 is equal to 1, so 1 is a perfect square of 1. And so on. 3 by 3 is equal to 9. So 9 is the perfect square of 3, right? And we can also have this in algebraic form. For instance, a times a is equal to a squared. Therefore, a squared is the perfect square of what? A. And so you can go on and give many other examples, right? And so here now, how do you know that a number is a perfect square? Or for instance, you want to find the square of a number, all you need to do is just to multiply that number by itself. Okay, so sometimes when you have things like 6 squared is simply equal to 6 times 6. Okay, so and when you do this multiplication, you will have 36. Okay, so some other examples we might see is, for instance, one is asking you to find or to evaluate 5 plus 1 all squared all over, let's say 7 minus 2 all squared. Okay, so this is just asking you to do the sum in the bracket. Remember the order of operation: bracket comes first, then off, then division, multiplication, addition, and then subtraction. This is BODMAS. Okay, so 5 plus 1 is 6, and then squared all over 7 minus 2 is 5, then squared. And so this is going to give us 36 all over 25. So when you simplify this, what you have is your solution. All right, so in this first part of this series, we are going to now see how do you determine whether a number is a perfect square or not. Okay, so apart from the fact that we know some of it, for instance, we know 1, we know 4, we know 9, 16, 25, 36. Yeah, we know 49, which is the perfect square of 7, and so on, 64, 81. Okay, so now if you don't know all of this, for instance, and you're just given a number or a number, an arbitrary number, how do you determine whether that number is a perfect square or not? And so we have examples here. It says, check which of the following numbers are perfect squares. Okay, so we'll probably see more examples here. All right, so I am going to be starting with the first one here. It says we should check for 36. Sorry, for 30. So how do you do that? Now, before we come here, whenever you have, from what we said here now, whenever you have a number as a perfect square, so it's actually giving you numbers in pairs. So 4 now is equal to the pair of 2 by 2. 1 is equal to the pair of 1 by 1. 9 is equal to the pair of 3 by 3. And so whenever you have a number and you express it as a product of its prime factors, it will be able to show you whether that number is a perfect square or not. If it's a perfect square, every digit that is found in that product must have a pair. Okay, so it must have a partner in a pair. So let's begin so we understand what I'm saying. So we want to express 30 as a product of its prime factors. So we begin with 2. 2 can divide, that's 15. 2 can no longer go, 3 can, and that's going to give us 5. 5 can no longer go, sorry, 3 can no longer go, 5 now is 1. So from here now, we can see that our 30 is equal to 2 by 3 by 5. Okay, and so from here, none is pairing each other. And so this is not a perfect square. Okay, so let's do this example of number 3 so that we can get this clearly. Look at number 3. We want to check for 36. Okay, so we draw our line. 2 can go here. That's going to give us 18. 2 again, 9. 3 can now go, that is 3. And finally 3 will go and you will have 1. So you can see here now that our 36 is equal to 2 times 2 times 3 times 3. Now, can you see what we're trying to say? Every digit that you got here in the divisor is actually in pairs. 2 by 2 a pair, 3 by 3 a pair. So, because every digit in this prime factorization of 36 is in pairs, so you say that it is a perfect square. But in this case, you only have one digit here. None is in pairs. So that is not a perfect square. Let's do another one for number 2 now. Okay, we can see for number 2, we have 52. Is 52 a perfect square? So let's check. Okay, we have 5, 2. Of course, 2 can go into 52 to give us 26. 2 into 26 is 13. No other number can go except 13. So you have 13 into 13 is 1. Therefore, our 52 is equal to 2 times 2 times 13. All right, so you can see here now that this first digit, which is 2, is in pairs, but the last one has no pair. Therefore, 52 is not a perfect square. All right, this one is a perfect square. This one is not a perfect square. All right, so and we can as well do for 105, and I will then allow you to do the last one. It's just a simple process. So for 105, we divide. 2 cannot go here, but let's try 3. Of course, the sum of this is divisible by 3, so 3 can go. 3 into 105 will give us 35. And then what again? 3 can no longer go, but 5 can go. 5 into 35 is 7, and 7 into 7 is 1. So our 105 is 3 times 5 times 7, and there is no pair here. Therefore, 105 is not a perfect square. All right, so I will allow you to look at this other one, that's the number 5, and show if it is a perfect square. So no matter the number you are given, in fact, if the number is large enough, let's even look for a larger number now. Okay, so let's try to look at this one. We said here we can divide with 2, and that will give us 700. 2 can still go. That will give us 350. Now 2 can still go. 2 into this is 1, 7, and we have 5. 2 can no longer go. Can 3 divide this? The sum of this is 13, and 3 can divide 13, so 3 cannot go. Let's try 5. Yes, 5 can go. 5 into 17 will give us 3. Remainder 2. Then you carry it here, that's 25. 5 into 25 is 5. Okay, 5 can still go again, and that will give us 7. Okay, 7 finally is 1. So we can see that our 1,400 is equal to 2. Okay, so at this point, now, is this a perfect square? Let's pair the digits. 2 is pairing with this. This one has no pair. 5 is pairing with this. 7 has no pair. Okay, remember the pairs must be together with the same digits, not just any digit. Okay, so 2 has no other 2 that is pairing with. 7 has no other 7 that is pairing with. So 1,400 is not a perfect square. So that's what this does for you. Without calculators, you can quickly know whether a number is a perfect square or not. Okay, so like I said, check for 196 if it's a perfect square, and drop your solution to the comment section. Kindly subscribe to our YouTube channel, share and comment and like our videos. In our next videos, we are going to see, okay, if a number is not a perfect square, how can we make it a perfect square? What's this minimum number that we can multiply to make it a perfect square, or we can add to make it a perfect square? And after that, we begin to look at the concept of square roots and of perfect squares and all of that. So see you in our next video. Bye.